Our group evaluated the effect of carbon dioxide emissions on the child mortality rate around the world. We looked at the data to see if there was any correlation that would permit us to look deeper into its relationship. This graph that you were shown is a comparison between CO2 emissions and child mortality rates. In 1940, for the vast majority of the world's population, CO2 emissions clustered under 0.5 ton per capita, and child mortality rates averaged between 200 and 400 deaths by age 5 per 1,000 people born. In 2009, CO2 emissions clumped together between 2 and 10 tons per capita, 4 to 40 times the 1940 levels, and child mortality rates collected between 20 and 60 deaths by age 5 per 1,000 people born, about 1/20th to 1/3 1940 rates. Because almost every bubble moves down and to the right, there is a distinct interrelationship between the two variables. This evidence suggests that as CO2 emissions increase, child mortality decreases. While there are other factors that influence child mortality, this correlation intrigued us enough to justify an analysis of the claim that increased CO2 emissions reduce child mortality rates. According to a study by Stanford civil and environmental engineer Mark Jacobson in 2008, carbon emissions are linked to mortality rates. However, Mr. Jacobson's results stand in direct opposition to the hypothesis made previously by our group. His results detail how for each increase of 1 degree Celsius caused by CO2, the resulting air pollution would lead annually to about 1,000 additional deaths and many more cases of respiratory illness and asthma in the United States. Jacobson estimates as many as 20,000 air pollution-related deaths may occur worldwide each year with 1 degree Celsius increase. Moreover, carbon emissions and child mortality rates are a direct cause and effect relationship, not just some bleak correlation. In Jacobson's own words, quote, "The study was the first to specifically isolate carbon dioxide's effect from that of other global warming agents, and to find quantitatively that chemical and meteorological changes due to CO2 itself increase mortality due to increased ozone particles and carcinogens in the air." End quote. Ceteris paribus, Jacobson found the true connection between mortality rates and carbon emissions, that they shared a positive correlation. Since this study was published, many other reputable institutions, such as the World Health Organization, have come to the same conclusion as Jacobson. In addition, according to the American Lung Association of California, infants and children are more averse to the health effects of pollutants than adults. This is logical because their immune system and developing organs are still immature. Irritation caused by air pollution is more likely to block their narrower airways. It also takes less exposure to a pollutant to trigger a breathing ailment due to the sensitivity of a child's developing respiratory system. Why then do CO2 emissions and child mortality share a negative relationship as seen on the Gapminder graph? Maybe there are other factors that have led to the decrease in child mortality rates that have outpaced the increase in CO2 output. Perhaps carbon dioxide emissions have grown hand in hand with economic advancement around the world, which in turn has generated better health and living conditions. Let's take a look at some graphs. Here we see carbon dioxide emissions compared with GDP per capita. As GDP per capita is a primary indicator of an average person's standard of living, it is the best representation of how efficient an economy is that we have. Nearly all points move up and to the right, indicating a positive correlation between the data, therefore suggesting that an increase in CO2 emissions corresponds to an increase in an individual's standard of living. This is partially true. A country's standard of living depends on its ability to produce goods and services. During the Industrial Revolution, consumer spending and investment, both components of GDP, greatly increased. Due to technological advancements such as the steam engine, telegraph, and the cotton gin, and more investment into physical and human capital, all of which are determinants of the production function, the quality of healthcare tremendously advanced. This improvement in healthcare resulted in a virtuous cycle which bolstered further economic growth. However, as industrialization/factorial production and transportation have consistently increased over the past 2 centuries, it has created a higher demand for energy, the bulk of which comes from fossil fuels. Unfortunately, the main emission of fossil fuel combustion is CO2. CO2 emissions do have a negative correlation with child mortality. However, as we have seen in this video, correlation does not necessarily mean causation. Supported by the accredited studies cited in this video, CO2 emissions actually adversely influence child mortality rates. The primary reason why the negative correlation between the variables exists is because of the steady global economic advancement, which has resulted in improved healthcare equipment, personnel, and techniques, and therefore a decrease in child mortality. That being said, greenhouse gases, the main being CO2, may be linked to the extremely harsh and unprecedented effects on the world's climatic well-being. Since there are no graphs of natural disasters versus carbon dioxide emissions past 2008 on Gapminder, we were unable to see the recent trend between the two inputs. However, the forest fires in California, drought in South Africa, record-breaking smog in China and India, and historically tragic hurricanes along the American coast, all in the past year, may be due to greenhouse gases. Hopefully, Gapminder will be able to display that data soon because it will help clear the relationship between CO2 and human deaths, indirectly by natural disasters and directly by smog inhalation. If fossil fuels continue to be the main source of industrial output, it is interesting to see what happens to global health, what subsequent effect that has on productivity, and how it could potentially lead to a drastic change in economic output, which has consistently grown since the Industrial Revolution, but could suffer in the near future.